I know that there's kind of a mix between technical and culture talks about DevOps. This is going to be fairly technical, but I'll try to highlight all the problems that we had when we tried to adopt Kubernetes at Honestbee. So, yeah, I'm currently DevOps at Honestbee, and I am one of the co-organizers for the Singapore Kubernetes User Group and Cloud Native Singapore Group, although the Cloud Native is not that active. So Honestbee is a company doing grocery and food delivery also in Indonesia, but in Singapore and in Malaysia as well. So if you want to have some nice food, check us out. So first off, I want to talk about a little bit about why you would want to adopt containers. I know that yesterday we had a nice talk about Docker, and it was very detailed on how to install Docker and what to do with Docker, but then there was a question about how to scale Docker, how to make it highly available. So I'm going to focus a little bit on that and focus a little bit on Kubernetes. Who here is already familiar with or heard of Kubernetes actually? Okay, so that's like 5%. Not so many people. Docker, I mean, that should be everyone. We were here yesterday, right? And then after I talked about Kubernetes, I'll talk about Helm and a little bit about secret management with Vault. So yesterday, it was quite detailed on what containers are. I'll just summarize in this one slide. So it's a way to package up your binaries and your dependencies and to make immutable and testable deploys, and to make sure that you isolate your software so you can share the same web application on the same host. I mean, multiple web applications on the same host. So to avoid a dependency hell, basically. And containers give you a very portable way of packaging up your application. So yeah, it's a self-contained process. So your web application runs in a very defined environment. So how do you start the adoption of containers? So at Honestbee, we found that the first step to adopt containers was actually at the CI/CD pipeline. So we were using Travis, but we started to move our CI/CD pipeline internally to have more control over the workers that we exposed to it. And adopting containers allowed us to set up very quick pipelines due to the fact that containers are so lightweight and are very fast to start up. So that's how I found. I mean, you can try to convince your developers to use containers, but every developer has their own workflow, and I found it very hard to convince people to use containers on their development machine. A lot of times it doesn't make a lot of sense, but it is very easy to introduce containers through the CI/CD pipeline. And once it's in the pipeline, then you have to start thinking about deploying it. So the first thing that containers provide you is a very strong way of versioning your application. So as I said, it's a packaged image, and it usually tagged with your with a certain version tag. So you can either use semantic versioning or you can use your git commit. So in this case, I have tags per branch because I have environment per branch, and I can relate. I'm running here a little make target that gets me the currently deployed version of my application, and I can go back to the actual Git repository and find back the exact version of the code that's running in production or on staging right now. Do note that latest is not a version, so do not use latest as a version because you're going to get in trouble. So once you've got your containers and you're ready to go, then you're going to have to overcome this huge cliff of taking the containers to production. So this is like a tweet that kind of highlights there's a lot more to worry about security, about how to schedule the containers across your service, how to optimize the resource utilization, and make sure that you monitor and take care of your containers, that if due to network connectivity issues, even the host is no longer available, or if there's your application crash, to make sure that it gets restarted automatically. And you also need to control who has access to do what, authorization, authentication, and scale automatically depending on the request that you're getting to your service, and provide discovery for your applications. So this is from a comic on the Google Cloud blog. It's a very good comic. I will share these slides and you'll be able to read the full comic. But this comes to a key slide where, okay, we're using containers and we want to use them in production. We don't know how to scale them. How do we do this? So there's this open source project from Google called Kubernetes. And there's like two notes on the bottom. One is that Kubernetes is the root of the word cybernetics. It's from Greek, it means helmsman. And it also Star Trek reference. Does anybody know what's the link between Kubernetes and Star Trek? Anyone? Okay, cool. So at least you're going to learn something. So there's Kubernetes is based on an original framework written by Google called Borg, an internal framework. They released a research paper about it. And when they were working on a new version, they wanted to keep the Star Trek theme. Does anybody know the name of the person on the left? Nobody? No Star Trek fans here? Seriously? The person on the left is 7 of 9. She's a very famous Borg. So this is Borg. Is based. So in Star Trek, the Borg is a species that assimilates everyone. But one of them is a human, and I don't know her real human name, but her Borg name is 7 of 9. And what's the link with Kubernetes? It has 7 sides. The logo of Kubernetes has 7 sides as a reference to 7 of 9. You can read more about that in the origin story that I linked there as well. So now, next time somebody asks you what's Kubernetes, you can, and tries to outsmart you, you can say, well, do you know the link? All right. Okay. So, so great, let's deploy Kubernetes. If you're just looking to deploy a small little web application, Kubernetes is probably overkill. So you start off with something small, like your blog, right? And you can actually, like as they were mentioning earlier, when you start adopting these new technologies, when you start to automate your processes, you have to start small. So we started out with sed, just some make targets, and we're setting the image name or the image tag inside our Kubernetes deployment. We either patch it, or we just use a template file and we just do this way. This works if you have a few applications. But we were starting to have more and more in Kubernetes, so then we wrote like this complicated Python Flask web application to just have like a deploy webhook with authentication and do all of this. Too complicated. But it was our version 2. This is how we used to deploy things on Kubernetes 2 years ago. And then we start to deploy more and more on Kubernetes. In this case, I'm just talking about one application, so we have like maybe 10 or so. And this one application has by itself already 10 components. We have the, we have an admin part of it, we have cores, we have core for bees, we have like all different components, we have different workers. All of these are different deployments of, in our case, the same application. Because we tried to introduce the concept of breaking down the monolith, but on our engineering side, it took a while to adopt. It's not easy to change your legacy applications, right? Your legacy applications are worth money, and it's very hard to change them. So oftentimes, it helps to lift and shift your application into Kubernetes. We kind of did something like that for our main core application, but we ended up with many different deployments of the same application. So all of these deployments have different requirements. I mean, here we have a dashboard monitoring our application in Kubernetes, and you see that the admin panel or the admin part is using 4 gigabytes of memory versus the core is only using 2 gigabytes and the actual B part is only using 1 gigabyte. So everything has different resource requirements, different response time, and different replica requirements. So that's a big challenge when you start to adopt Kubernetes. You have so many different deployments, and each application has multiple components, and each component has its own Kubernetes resources. So how can you manage all of this? The webhook, the templating that I showed you earlier is not going to cut it. The difference between the deployments are usually very small. Like we have a definition here of a deployment, and you see the difference is just the component name, the number of replicas, and the entry point. Because we have the same image, but it's running, the first one is running the actual server, and the other one is running a scheduler. 2 different Ruby on Rails components. So it's almost identical, but it requires a lot of work. If you have to maintain this in source control, if you have to make a change across all of them, it's difficult. That's where Helm comes in. So Helm is a package manager for Kubernetes. So the target user experience is to give you something like apt-get update, apt-get install, to just install something on your machine, or brew install if you're using OS X. I don't know about Windows, Choco, something. Yeah. So it allows you to collaborate on packages, sharing packages of open source projects. And it also actually is a deployment manager. So it allows you to do repeatable deployments and manage multiple configurations of the same application. So how does that work? I mean, first, Helm introduces the concept of a chart. So a chart is like a pirate map. It's a nautical chart. It basically lays out how you want to deploy your application on Kubernetes. Again, Kubernetes, everything is, apart from Star Trek, it's nautical. It's all shipping, containers, and boats, and helmsmans, and pirate maps. So charts are stored inside something called the repository, which is like a big library of all the different charts. And whenever you install your chart into your Kubernetes cluster, it's called a release. So you can have multiple releases of the same chart with different configurations. So in reality, Helm is really just a function that renders your templates, applies the values to it, and then creates a release. So it uses a Go templating language. Earlier I was showing you Python, Jinja. If you're familiar with Ansible, it's using that as well. So Golang is also a very powerful templating language. It has control structures, ability to add additional functions. So it's really powerful. And it's this, well, you actually can't really see it. But I think I highlighted the most important parts. I have a control loop at the top here, ranging across all of my API types. On my left side, I have the actual template, so it's quite complicated. And on the right side, I have the values that I use for this template. So here I have a definition that defines that I'm going to deploy an admin component and a core B component. The admin component is going to run a CPU target of 70%, and the core B is going to target 80% CPU utilization. So it's almost, I mean, it's very expressive on the left, which is my actual application configuration. And on the right side, I have my complicated template, which is something that I set up. But for the people managing the application, it's much, much easier. So now it becomes a lot easier to manage your deployments. So this is my advice, as we learned at Honestbee, as we adopted containers and Kubernetes, is to really look into Helm. It really helps you to manage your application. So deploying your application is just a matter of specifying the backend. I forgot to include the actual chart and the value. And then to just, you can have a look of all of your previous releases using Helm history, and you can easily roll back. So that's one of the key points of Helm, is that it gives you a way to manage your applications on a Kubernetes cluster. Okay, so out of this, at Honestbee, we learned that the Helm values are very important because they really define what your application configuration looks like when you deploy it on your cluster. So it's also important that you need to version those. You need to put them into source control. You need to collaborate on top of them. It's like your infrastructure as code, really. So you don't put any secrets in there. And I will cover how to handle secrets later, as I promised. Yeah. So I mentioned that charts and Helm gives you a way to share your applications with each other. So there's a public charts repository. If you go to there's a Docker hub where you can find public images of Docker. There's a public hub.kubeapps.com. If you go there and if you have a Kubernetes cluster, you can just Helm install from that. If you click on any of these, you can actually see the instructions on how to install, for example, Jenkins on your Kubernetes cluster. So this is maintained by people that are experts in Jenkins. They have created those charts for you, and they are keeping this updated. So you benefit from the whole community that's working on Kubernetes and on Jenkins using those charts. You can also host your own private chart repositories, because I don't think you want to publish your backend to the public repository, right? So at Honestbee, first iteration was to use a simple S3 bucket. And then we have an article there. I will share the slides. You can look the whole blog article of how we do this back in July 2017. The advantages is very easy to set up. Here we have like some semi-Terraform plan. And on the right side is the actual advantages, easy to set up. But the disadvantage is that your CI/CD has to be more advanced. You have to package the chart. You have to generate an index. You have to push it to S3. It's a bit more complicated. So all in all, this is how our CI/CD pipeline looks. This is how we do CI/CD at Honestbee, using on one side our Docker registry and our Docker containers, and on the other side we have an S3 bucket with our chart repository. So every time we trigger an update, the chart is downloaded from the chart repository into our Kubernetes cluster, and we actually do the application release using the Helm values. Yeah. Then what we are working on now is to improve our chart repository using the Chart Museum. So if you're interested in that, we have a drone plugin for Chart Museum. So drone is our CI/CD system, and it's also open source. And yeah, that's kind of new, Chart Museum. It's maybe 8 or 10 months old. So finally, this is the final point. I don't know what I'm doing on time. What's the time? Okay. So the final point was how to handle secrets, because as I mentioned, you have your application configuration all defined in source control. So how do you provide things such as API keys? If you work with third-party services, you need to provide those secrets, right? So in this case, we decided to use Vault. So Vault is a tool from HashiCorp to encrypt secrets at rest. You can back it by any storage like S3 or Google Cloud Storage or something else. And on top of that, it also recently added support for Kubernetes authentication. So you can use Vault and you can authenticate Kubernetes service accounts with Vault. That means that your application can get the authentication to pull its secrets. In our case, at Honestbee, when we deployed it, it was not available, so we used something called the Vault controller. So Kubernetes has this ability to define custom resources, and we're using it to define the resource called a secret claim. So with this, we are able to keep our application completely oblivious to the fact that all of the secrets are in Vault. To the application, the secrets are just magically inserted into the container. So the advantage of it is we didn't have to change our application at all. The disadvantage is that all of the secrets are fetched through the same service account, so you lose the auditability on the Vault side. Normally on your secrets, you want to know who's pulling what, but if everything is pulled through the same controller, you don't have the visibility. So we will probably look at improving that. Yeah. So this is then the final picture of how we are doing our deployments using Kubernetes. We are using Vault to store our secrets. We are using our chart repository, currently still in S3, but we are to Chart Museum, and we have our Docker registry. Okay. If you are interested by any of these technologies, we are hiring. We need DevOps. So I'm at DevOps Days. I hope I can get some people interested. And yeah, somebody took a picture of me. Okay. So yeah, there's one more thing, which maybe after all of this talk, after 2 years building this kind of infrastructure, I think this is a very relevant tweet. Everybody wants to manage infrastructure. They don't want to manage infrastructure, they just want to use a platform as a service. The problem is everybody wants to build their own platform as a service. So it kind of looks like what we are doing. I think the advantage of using Kubernetes gives us a lot of upstream flexibility. I think one of the questions on the first day was how can you keep up to speed with the rate of change in the environment. It's very hard, but if you have a dedicated team of DevOps engineers, and you go to conferences and you share your information, like as was mentioned, and you engage with the community, you can actually do that. But if you are a small startup and you're focused on delivering features, deploying Kubernetes is probably not something you want to take on unless you have this significant size to actually, take it into, do it yourself. Or you can use Google Cloud or AWS hosted Kubernetes. I'm not going to endorse anything. Or Azure. Or Bluemix or OpenShift. So, okay, that's it. Are there any questions? Yes?
Right. You talked about, creating these editors.
Yes.
Can I also package up my application in the cloud with these components and stuff?
So you're asking, the question is, I mentioned about these Helm charts, and you were asking if you're able to build the whole application as subcomponents of a chart. Yeah, so charts do have the ability to have dependencies and subcomponents. At Honestbee, I initially designed my chart that way. But I was having a backend chart and I was including Elasticsearch as a dependency. But we decided we wanted to manage those two releases separately. Elasticsearch is a separate chart. But yeah, you can create a very complicated aggregated chart with Helm. Yeah. Anyone else? Yeah.
Hello, my name is Roy. I'm from AXA.
Yeah.
Is there a standard pattern for doing flyway migration on Kubernetes? And if there is, can you enlighten us?
A pattern for migration?
Flyway migration.
Firewall migration? Flyweight. I'm not sure. Flyweight is a Spring Boot thing or something. I don't know exactly. Can you explain exactly what you mean by flyweight?
Just migration on Kubernetes from another.
You mean rolling update, across? Yeah. Well, Kubernetes by itself has the concept of if you change the image tag, it will automatically bring up a new version. And then depending on the your definition of the deployment, if you say like I can have maximum 30% unavailable, then it will start to create new versions. And if they don't come online properly, it will just stop the rolling update. But as they come online, you will have traffic being hit to the new version as well. So you need to be able to support, like you're not, your upgrades need to be decoupled from the database schema changes because you have two versions running at the same time and they will both be serving traffic. If you want to have finer control of how much traffic you send to the new version, you would need to look at more advanced things, maybe like Istio or things like that. So at Honestbee right now, we are still using the very basic rolling update of Kubernetes. We are not using Istio, but you have a lot more fine-grained control canal releases. You can do the same like blue-green deployment with Kubernetes if you set your max unavailable to 50 or max scale out to 50, like 150%. So it will create, you know, double the amount of replicas and then switch over. Yeah?
You're talking about values in the deployment.
I'm talking about the actual deployment upgrade strategy. So if you change your image tag, the upgrade strategy will determine how Kubernetes will you know, replace your web service with the new version. So that's what I hope I answered your question. Okay. I forgot where it is. Anyone else? Oh. I'm finished a bit early. Yeah.
Are you running the Kubernetes in GCP or AWS?
So we are using cloud provider. We're actually using compute instances. So we are provisioning it ourselves. We are using an open source project called KOps. And I go into very deep detail on how we do it. If you go to maybe my speaker deck, or if I can share the slides with people, I have a very detailed talk about how we are provisioning Kubernetes on our cloud provider. Yeah, we are not bound by bare metal limitations.
Curious for how you run the Kubernetes on the, let's say you should do it AWS, is it launch the instance or?
Yeah, so Kubernetes is quite complex to deploy. We are using an open source provisioner called KOps, Kubernetes Ops. It's part of the Kubernetes repository on GitHub. And it comes with like a node provisioner. So it's not using config management, it's not using Salt or Ansible or anything. It actually has like a little binary, a Golang binary that will pull your Kubernetes configuration and then configure every worker within the cluster as required by you. And it uses AWS scaling groups, it uses ELBs for service ingress. Yeah, we are running etcd in a high available manner. Like we have 3 etcd nodes. Every node is in a single auto-scaling group, and there's an automatic EBS volume attached to them. So everything is, it gives you a very quick way to start, but once you start like managing it yourself, you have to take care of a lot of things like upgrading and things like that. So our experience is that from the 4 people that we have in the team, there's at least one person dedicated. Like 1 man-month of time do we spend maintaining Kubernetes, at least. So it's quite an investment. And in that aspect, I think if you can use something like JKE or AWS EKS or Azure ACS, container service, it actually gives you a benefit. It's worth it. Yeah? Yes?
Can you share with us how do you implement monitoring with your Kubernetes?
Okay, so in the Kubernetes landscape, Prometheus is a very popular framework. It's come from Google engineers that were working at SoundCloud. It has a very good model. Like all of the Kubernetes components support Prometheus for monitoring. However, if you are a startup and you want to, take care of your monitoring yourself, you have to provision you have to provision the disk space, and you have to calculate. And if you don't want to take care of that, you can use hosted services like Sysdig or Datadog or something like that. So at Honestbee, we're using a third-party service. We're just running agents on our Kubernetes cluster that are monitoring our deployments, and we're getting all the metrics. So those pretty charts that you saw, luckily we didn't have to do much for that. We just had to draw the chart. That's it. Yeah. I think monitoring is very important. So if the whole system goes down, you have to have your monitoring up. So that's why we outsourced it. That's it? All right. Then thank you.